So we kind of need to revisit what logging is, just to understand. I know you do it all the time, right? But it's a log of what's happening, what a system is doing, right? What's happening right now. That's what a log kind of is. So it's also what happened. So you're looking back at history of what happened in your application. So basically, it's a record of requests and the outcomes of those requests. Yeah, it's quite simple. It's just you got to understand that and kind of remember that that's what it is. So logs are a stream of aggregated time. I nicked this off the internet. I didn't cite it. I'm sorry. I don't know where I got it from. Aggregated time-ordered events. I would never say this stuff. Collected from the output streams of running processes and backing services. Right. So logs are streams of events. And an event is quite an important thing. Right. So when you do logging now, what if I thought of a log before? I'd kind of think of a log as maybe a string. Yeah. When you're writing something out, you're trying to write a string to a file. I did this, and this happened, right? When you start to think of an event, if you change your idea, this is an event that I'm logging. And an event is something that happened at a particular time, and it has particular attributes, right? So if you think of it, rather than just you're writing out a string, you're writing out an event, you're writing an object, if you're object-oriented people or whatever. So just remember that, because it's a stream of events, a stream of stuff happening. And you need to keep a kind of history of that so you can look back. Who uses logs? Does anyone not use logs here? Because you use it for loads of different stuff, right? So as a developer, when you're running your Maven build, or I don't know, you node people, if you're running NPM maybe, yeah? Yeah, NPM, you have a log of what's happening. You're using it in your development, right? It helps you. Oh, I've got a compile failure. That's useful, because if you didn't know, you would spend a long time trying to figure out what was wrong, right? So you use it when you're running a system, so you can look back and go, these things. You use it for troubleshooting your system. You use it for learning about behavior of your system if you haven't thought about it before. And sometimes even if you have thought about it before, your kind of logs mean you learn the things you didn't think about before, right? So anyone involved in creating, deploying, running software, using software, needs logs. You all need logs. So you've got to be excited about it. Right, which you were, which is great, right? Because you're going to see them all the time. So if you're not excited about something you see all the time, you know, like washing up at home. You're not excited about doing it. You need to change your relationship with it, right? Get excited about washing up. Get excited about logs. I think this is deep. Right. So traditional app logging. The actual logging strategy. I don't know why I'm looking now. It's here. Are defined by the system, right? So when you write your system, you're choosing, I'm going to write this log to this file. I'm going to write that log to that file. And we'll see why that doesn't quite work with microservices, but that's what we're doing anyway. The storage and routing of those logs, so I'm going to write it to a local file system, and that as an application, I really want it to be there. It's nice and safe and secure. Or I'm going to write it to a remote system. It's kind of the responsibility of the system, the application, to do it in traditional worlds, right? Again, fine, but maybe do things better. Write to local file, most of you probably do that now. Is that fair to say? Yeah? And why that doesn't work with microservices, we'll get to. Some of you centralizing your logs? Some? Put your hand up. If you've got hands, yeah? Yeah? Some of you? Good. Fun? Splunk. We don't talk about things like Splunk. I'll show you the free alternative. Right, so yeah, Splunk's an awesome tool, right? There are some really good open source alternatives, and I will show you. I will do demos of two things today, and there'll be things that are similar to Splunk, maybe not quite as all-encompassing, and certainly not as expensive, but we'll get them. Right. So it tends to be a custom configuration per system, right? So I'm really glad you bigged it up, because people are like happy. It was all because of you, right? So it's a custom configuration per system, right? So you writing your system, you'd probably write your own little log configuration. You writing your system, your own log configuration, yeah? And you might have totally different ones, right? Because you prefer one in one way, you prefer it in a different way. Because at the end of the day, you're going to be the consumers of the logs, probably, right? So you want a certain format, you maybe want a different format. And microservices and the kind of cultural aspects that come with microservices, the DevOps approach, mean you need to kind of talk and you need to be consistent. So maybe that doesn't quite work. I'll just skip straight to containers, because if we're doing microservices, we're pretty much doing containers, right? Especially in today's discussion. They kind of go really well together, and forget that I probably mentioned Docker, because I don't want to offend the Rocket users, that things are a little bit different. It helps us to kind of think and maybe standardize on other things, because containers standardize the management of your processes. So we've had like a talk about Wildfly Swarm, and the way that we start that, the way we start Wildfly. If I'm starting I don't know, some other app, some native executable, I'm starting in a different way. If I'm running in a container, I just do a Docker start or Rocket equivalent. It's standard, the way I'm doing stuff, right? I'm starting, stopping stuff in the same way. So can we standardize the way we're doing logging? And that's what I'm saying. If you're going to be deploying into an architecture, a microservice architecture, you need to be consistent in the way you're doing it. So you need to do it in a standard way for your organization, but there are some things that maybe make a lot of sense, like logging to standard out and standard error. Right. So we talked before, logging to files. Logging to files doesn't really work in a microservice architecture, in a containerized microservice architecture, because my containers, they might go, they might die, right? And that means your logs are gone. Okay? So as soon as my container's gone, my log is gone. What's that? I don't even know when I'm funny. It's great. So you've got to understand, right, that logging to standard out and standard error, it sounds a bit weird. It sounds a bit weird that actually this can cater for all of our needs. These two simple things can cater for all of our logging needs, right? I send my normal events, my normal run-of-the-mill events to standard out. I send my erroneous ones to standard error. It really is that simple, by the way, so it's not clever. The execution environment, the environment where stuff is running, captures those streams, right? So your application is just responsible for writing the events out, and the environment where it's running, the execution environment, Docker, say, maybe, will capture those streams and then do something with it. It's not the application's responsibility. The only responsibility of the application, the system, is to write to standard out and standard error. Every single one of your applications should do the same thing, and then delegate, or not delegate, go, that's it, I've done my job, right? And let the execution environment do the rest of the stuff. It's also rooted by the execution environment. If you've used Docker, there are different, what are they called? Logging systems, right? So you could just use straight to log to file. You can also log to fluentd, or you can log to what do you call it? syslog. There are other ways of doing it. So the execution environment is taking your logs, and the execution environment is doing stuff with them. It's routing them, sending them on somewhere else, right? And I mentioned that before. Containers are ephemeral. You've got to, like, as Tim mentioned earlier, you've got to start getting detached from your containers, right? Your containers are going to go, your logs are going to go if you've been writing those inside those containers. So you have to centralize, which is, someone mentioned Splunk, and I say, we'll get onto that, but you have to centralize your logs. So the few people that were doing it, the ones that aren't doing it. Right. Even if you are running traditional applications, right, even if you're not ready to move to microservices, just centralizing your logs, you'll find it so much easier anyway, right? Now, we talked about an event, and we're logging, we've got to log with context. So when I see an event, what does that mean? If I just have a string, actually, let's do this first. Logs are for machines, really, not humans. You're writing your log out as a nice, probably, maybe quite human-readable thing. Johnny requested this image, and this is what I sent him. Or this event happened, this error happened. If we start to think about events as something that are passable and usable by machines, to then present the data differently to you, so you can get more data, more info out of it, and gain more out of that, then again, your relationship with logs will change. If you're just writing a simple text string that only you're going to be the one that reads it back, and every time you've got to trawl through the logs to find stuff, you're going to get tedious, like the tedious washing up, right? You want to make it kind of exciting. And the context gives those logs power. So if I'm just writing a simple string with no real context, it doesn't become usable outside of that environment. Right? If I give context, if I put context into that log, it lets me look at it later as well, rather than just right now and understand what's going on. So the context allows me to look at an individual event even. So there are different ways of getting context. We could infer context by passing a log line. So if you're logging in a particular format, we could pass that. I'm sure you've done it. If you've done it with Splunk, you probably had to put some regexes in to go, this is my format of my log line, and this is how I'm breaking it down, which is fine. But it's easier if we just log with that context straight away. And that's what I like to call, what other people call structured logging. This is an unstructured log. This is a log line with no context. I hope they can see that. There's no context in this, it's just a simple string. It's pretty unusable, right? Unless I go and find it with all the other log lines that go around it. It's not usable by itself. It's readable by humans, but it's not as usable as it could be, and you need to make your logs as usable as you can. So I can do this. I can make it passable. Those of you recognise that, it's an Apache log line. It has a particular format, right? So I've got the IP address of the requester. I've got a user ID in there. I've got a time. I've got a verb. I've got the URI. Blah-de-blah-de-blah. I've got information in there. But the only way for me to get that is to infer the context out of it, right? So I have to pass that, and normally the only way to pass that is with a regular expression. And who loves regular expressions? I do. Yeah, but they can get funky, right? So that's yeah, it's good. I like it. It makes you feel like, yeah, I'm really cool. But it is funky, and actually it's really tricky to cater for things like multiple log lines, right? Java world or most of the world, you have a stack trace. How do I deal with that in these situations? I'm having to infer context. I'm actually having to put processing power in to infer context out of a string. So I'm wasting my CPUs. I'm wasting my cycles getting context out of something that actually I can do something really simply and log with structure. Can you read that? I hope you can see that. It's basically log as JSON. It's a really simple idea, right? But I've straight away got this stuff here. I'm not allowed to walk in front of the camera, so you can see where I'm pointing, right? No. This stuff's already got the context in there. The status, what was the response code? What was the request? What was the request to host? What was the refer? Blah. The context's all there. I don't need to infer that. I, as an application, can log straight away with context. I'm not wasting my CPU cycles. I'm just logging with context. And what that lets me do is it lets machines read it. A machine reading that, it's just a string unless I get the context afterwards. I tell the machine to get it going. The machine straight away can do stuff with that, right? It can index those things. These fields can be indexed. JSON is a really nice format. So it makes it filterable and searchable. If you've ever logged to just a file and you go, using grep or whatever you do on Windows to find out, to find a particular error, this lets us go into a nice UI, Splunk-like UI, and search for stuff, right? It lets us do that by simply doing that. That's a really easy thing to do. So where do I get that context from? Because there's two parts to context, right? This is a context of a particular request. This is the context that an application knows about. Skip over that bit. The system is aware of context, right, of these kind of things. But when I'm logging in a microservices, there's extra context that you need somehow to get it in. If we're looking at Kubernetes, what namespace is this running in? What's the name of my pod? If you remember what that is, good luck. What labels are there on this stuff? The execution environment is the only bit that's aware of the context at that level. The system doesn't know, or shouldn't, it can know, but don't worry about that. There's no need for it to know what namespace it's running in. So we need to be able to enrich that information. We need to add that information in. So later on, I can use the same kind of things that Tim showed you to cut and slice, with labels. Can I do the same thing with my logs? Yeah? Oh, I tried to skip that one. Oh.
So this still assumes that the semantics and meaning of these identifiers is known in the machine. Because how does the machine know that my status is more status is going to be something else when it becomes false?
Right.
That requires some specification to be already put out there. This is the standard specification.
So not quite, right? So this is my application logging. So a machine doesn't really know about context, right? Because context is a kind of human concept. Yeah. A machine, what does a status mean to a machine? It doesn't really care. It's just a string in that case. Probably should have been an int, but anyway. It doesn't really care. So all we're asking the machine to do is take this information, index it, so that I, as an understander of that context, can then go and use it and make more use of it, right? Whereas this way, I'm having to I'm having to split it all down. So the context, all these things, they're all human concepts, right? Absolutely. Yep. You can do structured logging however you want. The reason I've said, and it's true, right? You can give structure in different ways. Absolutely. I would, if you want to build your own system to then do that parsing and do the indexing, that's fine. But JSON, and we'll talk about JSON, is this really cool format that if any of you use Elasticsearch, and this is why I'm saying JSON, right? So. No. Yep. Yep, but the CPU cycle is going to be used anyway. So if I'm using a regex to pass a string, and then I'm indexing it, I've got to do the indexing anyway. If I've just got something already, I'm just indexing it, I'm stripping away that whole step. Yeah. So the reason you said JSON is because when you see it in a minute, and I'm using Elasticsearch in Kibana, by the way, it's not any big secret. JSON is indexed. Oh, I've done that. No, I haven't. Right. JSON is indexed natively by Elasticsearch. It's a store for JSON documents that do then full text indexing. So we'll see that in a sec. So just want to break from one thing and just remind you what a microservice is. Microservice is a thing with a limited scope of responsibility. We've talked a lot about microservices being something like taking web requests, HTTP, REST service. It doesn't have to be that, right? This is a microservice. Our microservice is actually going to be our collector of our logs, right? Our microservice is going to be another microservice. It's going to be our storage of our logs. Another microservice is going to be, our indexer. Another one is going to be our microservice for viewing those logs, right? But think of microservice things with a limited scope, because what you're going to want to do in a microservice architecture is start to compose different microservices. You're not going to want, you're going to have different parts, and we'll do the same with metrics in a minute, by the way. You're going to want a microservice deployed that can then do stuff with your logs. So what we're going to say is a microservice to collect your logs, a microservice to store and index your logs, and a microservice to view your logs, right? So forget microservices just like REST or just messaging. Microservice is just a thing with a limited scope. And I think really that idea of a microservice composition is really, really powerful and useful. So it's kind of a subtext. And obviously I know you're running on these platforms already, so we can centralize with three basic tools: Elasticsearch, FluentD, and Kibana. So these are our basic individual, what we're going to call microservices, because what they do: Elasticsearch, storage, FluentD, collector, and Kibana viewer. So Kibana. So Kibana is from the same company as Elasticsearch. These are all open source tools. Obviously, I don't really like anything else. So these are free to use, and yeah, pretty awesome. We're working upstream with Google as well. Don't need to mention that really. Deployment, really simple, as most microservices deployments onto Kubernetes are. Replication controller and service, remember that for Elasticsearch. Replication controller and service for Kibana. Static pod doesn't really matter, you don't really care about that, but it means running something on every single node, basically. And we hook them up via Kubernetes discovery, service discovery. So we talked earlier, I think James Strachan spoke about service discovery. So there's nothing there's no hard coding of IP addresses. We're using, in fact, just DNS to do service discovery in this case. And it gets every container's log centralized. So, right, let's do a demo. It's really weird because it's such a small. Yeah, that's great. Is that too small at the back? Is that all right? Yeah, cool. So you can see we've got stuff in here. I mean, it's not really an exciting demo of stuff being in your logs because you've got your logs. They're in Elasticsearch, and wow, I can now see them. But as you can see, what we've got is some context here, right? I am going to walk, sorry. We've got the execution environment context. So we've enriched that. I don't know if I need a microphone, but I do talk loud. We've got the execution context already in there. This is added by our FluentD microservice, right? We've got a log message now. This is where things get a little bit funky, right? So we've got different stuff logging in different formats because sadly not all of my stuff logs. This is obviously for demo purposes. Not everything logs in the right way. This is a camel exchange, so I blame Klaus. It's logging just as a simple string, all right? He could do better. We've got stuff here. We've got JSON. So Kibana is doing it all right. It's already logging as JSON because it knows normally people will then ingest the logs from Kibana into Elasticsearch, right? They work tightly together. So I've got stuff there. Now, if I skip to another dashboard, there's no results because I've got to do something that I've forgotten. And now I can't see where it is. Oh, I shouldn't show you these things. This is just no. This is don't worry about that. It's nothing. I don't know. Right, that's just a photo, random photo from Flickr, right? And I'm glad it's that and not other things that come up, right? So I'm going to disable that now. Right. Now I've just got embarrassed. Right. So this is basically just an Nginx that I'm running up, showing Nginx logging. Nginx is just a web server, if you don't know, like Apache web server. Logging in the other format that I mentioned, the non-parsable format, or the parsable format, sorry. And here we go. Stuff comes straight in to here. This is, here you go, from that pod. So it's come into here. There's a slight delay because when you're ingesting a lot of logs, and this is another thing why your microservice comes in so handy, you do stuff like buffer your logs. So if I'm writing lots of logs at the same time from lots of containers, I don't want to pump individual events into Elasticsearch in this case. I want to batch them up and put them in because if I'm doing lots of logging, I don't want to slow stuff down. So I batch it up, buffer it up, and push it in. There's a slight delay. But you can see that actually the log is a little bit boring, right? It's just a string. It's the same as Klaus's poor camel attempt. But if I do something a little bit clever, and I've just literally, this is just configuration of Nginx. Just hitting the little pod, and I go back to here. I can see, if I can scroll down, that actually, the context that I mentioned before is now indexed, right? So what could I do with stuff like this? I could create other dashboards. I'm not going to because I didn't. But I could do stuff like, well, these are all 304s, but I could do stuff like what proportion of my requests were successful, so I can look at my logs and get loads of information out of it. And that's really cool. Rather than just being a string, which isn't that useful, I now can get ideas about how my application, how my microservices are performing. Now, if my pods go away, that's fine because all the logs are being centralized, so I don't lose any of those logs, right? This information is kind of gold dust that you're probably missing out on when you're just logging to a file. If you're not centralizing, if you're not indexing, you're not getting the full value that you could out of your logs, right? Some of this stuff that you can do better with metrics, which I'll do in a minute, but stuff like what's your most 10 popular pages on your website? I don't know. Stuff like that. This is where you get it from, your logs, right? Nice and simple. Well, that's kind of logging done. If there's any questions about logging? Okay, so there's the reason we're using FluentD was mainly because the upstream Kubernetes was already using FluentD. I think Google used FluentD, yeah? So that was one of the main reasons. It was kind of just to enhance what they were already doing. FluentD is an event collector. Yeah, so if you've used Logstash, they have Logstash Forwarder or Logstash. The reason FluentD for us was a better approach was if you're not running a full Logstash on every node, you have to run a central Logstash, right? And that becomes quite large because it's got to accept all those logs before it pushes it into Elasticsearch. FluentD takes the case of I'm going to process logs basically on each node. So that's why we do it because then we can scale more horizontally. And it's a really lightweight. It's mostly written in C. So it's a really nice approach. Yeah. So.
I think you answered the question, but just a follow-up. How do you get the container logs, the standard out, standard error to FluentD? Do you need to do anything on the container side?
Yep. So remember I mentioned earlier that the execution environment, Docker, it's capturing those streams. So in an Nginx way, all I've done is just say, write your request, your access log, write it to standard out, and your error log, write to standard error. Just configuration of the config file. Same if you're writing in I don't know, log4j. I can't remember Java. It's been ages. So log4j, XML, or whatever. You'd use your console appender, right, to write to standard out. And I'm sure there's equivalent for standard error. So there's always ways of doing it, but yeah, it's about your logging configuration.
Can I change the log levels on demand? Let's say I'm trying to debug something, I want to switch from let's change it to the debug level.
So that would be, yeah, right. So that's up to you, right? Because I'm not actually, what this is a microservice for capturing your logs. It's your application that then has to say whether you can change the logging level, right? Because I'm not doing the logging, I'm just capturing them.
Now if I'm running in a container and I don't know when to run a pipe pods, I have to find those pods, change the levels. Can I externally send a signal?
Right. So what you would tend to do in that case is actually spin up more pods. So you would do it normally. You would do a config change and a rolling upgrade.
Just for taking the log level and spin up more pods.
Yeah. Yeah. It sounds a bit weird until you get used to it. But that idea of any config change, right? The reason is your pods are ephemeral, right? Your containers are ephemeral. If I make a change to my container and it dies and another one gets started automatically by Kubernetes or whatever, then I've lost that config change.
Or your microservice can have a service which you can call and test that log.
Yep.
Yeah,
Yep, you could absolutely do that. There's no problem with that. But like I said, remember that it's ephemeral. Okay, so if that pod dies, it will be gone. So if you're looking to debug potentially an error that's happened over a period of time, it happens intermittently, and you're only going to know about that because of your debug logs, then you're better off changing the config and then doing a rolling upgrade, right?
Plus you might just want one pod at detail logging, 90 pods not. So rather than every single pod that has detail logging, just have one pod that has detail logging. So like 1% of the traffic has detail logging. So you're not getting terabytes of data logging.
Yeah. Yeah.
To add to that, as a point towards like auditing, you don't want to be randomly changing things in production that aren't like checked into source control somewhere.
Yeah.
You know, in terms of best practices.
I mean, it is a big shift, right? This idea that my running process actually doesn't matter. It can't, in a microservice architecture, in a scalable microservice, you can't let it matter to you, right? None of my pods should all be identical as much as they can be, and any changes to those should be done through a repeatable process, right? So if I'm going to make a change to config, it needs to go through.
To emphasize that even further, Kubernetes will actually hash the config that you fed it when it creates the Docker container and use that as part of the Docker container name, so that if your config changes at all, we recognize that what we're running is not what we're asked to run, and we'll kill it and restart over.
Ah, is that what? I didn't know that.
That magic numbers at the end of it.
Right. Yeah, so don't do it. I'm glad you're here. Okay, so let me skip to here. If I do, quite a lot of you said you use Docker, right? So if I just show you the running Docker processes, it looks rubbish because it's so squeezed. We can see that every Docker container doesn't have an ID, or has an ID, but it also has a name. So I'm guessing what Tim is saying is this part at the end of the name is actually a hash of the requested config for your pod, right? So what Kubernetes is saying is, if I do a hash of what you've requested and it's different to what's actually running, ooh, that's bad. So I'm going to kill it and I'm going to spin up another one with the correct config, right? Yeah, yeah. 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 So the guy down here was just saying, if you couldn't hear, that Elasticsearch is really awesome, right? He didn't say that bit, I said that. But it really is, right? He meant it. I know he did. And it's totally scalable. It's a really cool environment. It is cloud native, whatever that really means, for this. But there are some provisos around running it. Okay, so there are some scenarios when you can have data loss, I think is what you're getting at, and maybe data inconsistency. And there are some little nuances around, for example, indexing fields with the same name, stuff like that. So just be aware of those. It's not a total panacea, right? So there are things, and it's called Elasticsearch. Call me maybe. That's great. That's worth looking up. Can you?
Products like that. There's a company that actually does.
It's the Jasper series
There you go.
on distributors guys. Jasper.
How long have we got? How long have we got?
Like
10 minutes? Yep, good.
yeah, 5, 10 minutes.
10 minutes, yep. So we've, because they really want to see this. They haven't seen it. It's great. So you've centralized all your container logs, right? I didn't get to this last time. But, can we do the same for your metrics? And obviously we can, right? So the same reason of logging. Why do we collect metrics? Logs tell you what's happening. Metrics measure that behavior, right? So they tell you how well it's happening or not. And that allows you to measure improvement or otherwise of a development change. So when you're doing, for example, a rolling upgrade, and you go, hang on, I'm going to compare my previous response time to my new response time. Ooh, that's not gone well. I'm going to roll back. Or it's gone brilliantly. This is the benefit of doing it. So metrics allow us to measure our improvement, which is really important. I know James Warnings is probably going to talk about this idea of continuous improvement, not just about continuous delivery, but how you're measuring what you're doing and how it's improving. You know, your processes, how they're improving your software. But also you can use stuff like metrics for things like adapting to behavioral runtime changes. Autoscaling is a great example. Someone, I can't remember who it is, was maybe going to do a pod autoscaler demo. That uses metrics, right? Because it says, oh, look, my CPU's running really hot, 100%. I need to spin up some more pods, right? So we can use metrics to then adapt to what's happening in our environment. What metrics should you collect? Resource utilization, which skip over, get to it in a sec. Application level metrics, and whatever else you want to use to improve. So, for example, we've started capturing stuff like Jenkins build times. Right, it's nothing actually about my running application, but what changes am I making to my application? How's that affecting build time? How does that correlate to my number of deployments that I'm running? Is it slowing me down? Is it speeding? These things, they're really important. It's not just necessarily about your application at runtime. So think about it. Resource utilization, simple things, CPU, memory, network, and file system, I/O. Basic stuff. Now we talked quickly about the consistency of logging and how you're going to log to standard out and standard error, and that allows you to capture everything in the same way. This level of consistency gives you something even more, right? It lets me compare my JVM, or my Java version of an app, as Kian talked about earlier, their migration to Node. Hang on, what's my resource utilization like? How does it compare that I've migrated between two things? Is this worth a further migration? It lets you go, this is an improvement definitely between technology stacks, as opposed to just necessarily a process level change. So I can compare similar things for any kind of application. They're generic, right? And this is where C groups come in. So in the Linux kernel, there's a feature called C groups that it allows you to do stuff like limit how much something can use. So when I'm running an environment, microservice architecture, I need to make sure that stuff I'm deploying doesn't consume too much. Right? So if I'm putting 1,000 pods on a node, I want to make sure there's enough resources on that node to run 1,000 pods. So I can use C groups, and it can all be configured through Kubernetes manifests, right? Say only give it this amount, don't let it go any further. I can do that for all these things, for CPU, for RAM, swap, and I can do disk I/O, network even as well, and sometimes.
All those resource allocations differ in the release of Kubernetes.
We currently support
C-
CPU memory.
Yeah. Yeah, which is no file system at the moment.
We're working on it.
Yeah. So sorry, the question was at the moment if you want to do limiting of resources, you can only do CPU and memory at the moment in Kubernetes, right? C groups allow you to do lots more stuff, but there's a kind of how you configure that, and it's coming. Tim promises. Docker uses it. That's one reason why it's kind of really useful, because as soon as you spin up a Docker container, it's already there for you. It's all done for free. You don't have to do anything. And all of these things are in isolated namespaces, which means, for example, if I'm in a pod, Tim mentioned the networking model earlier. I don't know if you really care about this, but you might do. my network namespace is isolated, which means I can actually track the network usage of an individual pod, in this case. So normally, if you're running Docker, you can do that on a container level. What we're doing now in Kubernetes is taking that to the pod level. So all of my containers in pod, how much network utilization is it using? Really useful. Same with CPU and PID and everything. Resource limits. And accounting is really what we're interested in when we're collecting metrics. Yeah.
All this measurement that you're talking about, is it available out of the box?
Yep. Straight out of the box.
So just turn it on.
Yep. So the question was, is this all? You don't even have to turn it on. It's just on. Right. You do nothing, you get it. Right. It's cool. What? It's a really good deal. Yeah. Most of the time, you don't even know it's there, right? Because unless you start going, hang on, I want to start using metrics. You may not even know it's there. Most of it's just done totally quietly, and you don't even notice. They won't even touch it. So accounting is what we really care about with metrics, because accounting means how much am I using. I'm collecting. I'm doing accounting of what's going on.
There are a couple distros you have to turn it on.
But we don't talk about those. They're not Red Hat.
There are some that need kernel flags.
That's true, actually. Right. So yeah, I can't remember what they are. But if you're running on some Linux distros, do mean you have to enable C groups, but it's a requirement of running Kubernetes, is it? Yeah. But it's a requirement of running Kubernetes. So if you want to use Kubernetes on some random non-Red Hat distribution, then subpar, yeah. I didn't even know there were any others. Right. So. Yeah, so it comes out of the box, literally don't need to do anything. So how do we get the metrics? Oh, I've got loads of time. CAdvisor and Kubernetes. So CAdvisor is embedded inside Kubernetes, inside a kubelet which runs. So all these things are, again, automatically exposed for you. You do nothing. It's just there. And we can collect those with two things. We can collect them with one thing. So again, microservice to do the collection. And that beautiful symbol is Prometheus. Right? If you've not heard of Prometheus, it's a metrics a monitoring system from SoundCloud, totally open source. Again, obviously only open source exists. And Grafana, which was like an early fork of Kibana, but now does only metrics and does nice, lovely graphs and stuff. Which again, I will show you. Deployment. You see the way you do deployments, right? It's quite simple. And that's every container. So, application level metrics. So what we've caught are your container level metrics, your consistent generic metrics. We can also use Prometheus, which I'll show you again in a sec, to collect metrics from any of our applications, right? So I'm going to show you briefly some metrics from a JVM. I'm going to show you some metrics from HA proxy. If you don't know, it's a proxy server. I'm going to show you some metrics from something else. Oh, from Kubernetes itself, even, because that's still an application, right? So I'm collecting metrics from a Go application, a Java application, and C, I guess, HA proxy is, in a consistent way. All I'm doing is exposing those metrics over HTTP. So just like before we said, where we're sending our logs to standard out and standard error, what I'm going to do with metrics now is I'm going to expose them in a consistent way. I'm going to have a little HTTP server that goes, okay, here are my metrics. So I'm going to collect them in a consistent way. Yep. So Tim talked about labels earlier. What we're doing with this collection is with Prometheus is actually to reuse those labels. The question was, can I group metrics from pods really that are back in the same microservice? I guess that's the question. Yeah. So yes, absolutely. So what we actually do is we annotate using labels in our metrics. So we actually reuse the Kubernetes labels in the metrics here. So you can use the same one when you do that -L pod equals Jimmy or app equals Jimmy. I can do exactly the same when I'm querying Prometheus for those metrics, which is a great consistency, I think. There are client instrumentation libraries. There are external exporters, so it means I can write my own code to expose my metrics, or I can write an external exporter to go and collect my metrics from, like MySQL, which doesn't have any native Prometheus instrumentation, but I can have an exporter which goes and collects those metrics and exposes it in a Prometheus format. Right, so there's multiple. It has SNMP if you're like into your hardware routers or whatever. Kubernetes and OpenShift extensively instrument and discovery. So let's just try it out and Oh, this, for example, that's okay, you can read that. Oh, it fits. So this is collecting metrics from Kubernetes. So what we've done actually is Prometheus, a little bit of configuration, all out the box, really simple config file. Go and collect these metrics. You can see stuff like the amount used in my whole cluster. I've only got one node, I'm very poor. I can see the amount of memory totally available in my whole cluster, the amount used in my whole cluster. I can see all these stats just by the metrics I've collected from Kubernetes and OpenShift, right? I've got some other dashboards in here, for example, HA proxy. I can see stuff like the responses that are coming back from back ends or from front ends. There are two separate things in an HA proxy. I can see stuff like data out, not very much because my website's not popular. Things like that, right? So I can also see how healthy they are. If Prometheus is unable to get metrics, then it kind of goes, well, that's not up anymore, so that's unhealthy, right? So then we can also build stuff like alerting, which I don't have any time for, which I wasn't even going to do, so it's great. Now, this is quite interesting, actually. If I take HA proxy as a good example, this is like an overview of HA proxy. And actually what this would be if I had multiple HA proxies would be them all in one kind of overview. What you can do with dashboards and what makes it really nice and really, see, if I had 12 HA proxies, I would see obviously the sum of all that stuff there. What I can do is start to drill down into individual ones, or even drill down into individual backends. So the actual pot. Oh, there you go. Yeah, forget that. Right. So, you see, it's healthy, yeah. So I can see individual backends. I can then drill down actually into individual parts of my application. So that's kind of what you want to do when you have dashboards. Overview, drill down, drill down, drill down to more details, right? And that's what we can do with the aggregations that we can do in Prometheus. So that's HA proxy. Prometheus even has its own kind of instrumentation as well, of course, it instruments itself. And JVMs, all I'm going to show you is some stuff here. So this is what we call application level in our cluster. We can see we can do stuff like selecting the namespace, which is the Kubernetes namespace, the service, the Kubernetes service. So we're grouping stuff together already, and then the individual pods. So if there are more, there'll be stuff there. This UI is Grafana. So this is new. So Prometheus had its own dashboarding tool, which was cool, but it only worked with Prometheus. Grafana is a tool that ops people will probably be a bit more familiar with. It integrates with multiple backends. So if you use InfluxDB or OpenTSDB or KairosDB or other ones, the same visualizations are applicable to multiple actual data sources. It's got a massive community behind it. It's really very cool. And yeah, so this is in the latest version, 2.5. Prometheus is first class citizen in Grafana. So Prometheus does have. I'll show you the Prometheus UI. It's not pretty. So here, I was going to show you the auto discovery. Right. In fact, I'll do that first. These are the targets. I'll scroll down to this one here. Right. So we can see that this one. See these labels, right? These are the Kubernetes labels. Yeah. So that's what I was saying before. We're capturing them in the metrics, so we can use those in our queries. The same ones we're querying Kubernetes for our resources, we can do with metrics. And the last thing I'm going to do, because this is just going to blow your mind, right? I'm going to do a scale. You probably can't see that, but if I do that. I'm just going to scale up one of the applications we were collecting, which was a Klaus's Camel CDI. CDI and Camel is brilliant, by the way. And I'm going to scale that up, and we'll see, promise, that, oh look, we've automatically got, I've done nothing, right? My application hasn't said anything about it. It hasn't tried to say, I am here. We've discovered new back-end pods from the Kubernetes API instantly. And as they scale up and scale down, we'll stop collecting, we'll start collecting. Right? It's cool. So hopefully that'll say healthy now. Yeah, healthy. So we're collecting all those metrics now from all three of those pods, which is nice. So if I jump back into here and do this, refresh the page, I can see now I've got all those pods available, right? There was only one before. That's it, really. Any questions? I'm sorry, metrics was so good. That's the first time I've seen it, and I know they're just blown away by that. But the thing really I want to get to is, I do have something to finish on, don't I? Yeah. In summary, logs tell you what's happening. Metrics measure how it happened, and you can use microservice to capture. And centralizing everything is kind of key, right? Remember, your pods are going to go away. Centralize everything you can if you want to keep it, really, is what I'm getting at. And I didn't say that. Yeah, using microservices spelt wrong to capture stuff is really important. Composition of microservices around it. Don't just think of a microservice as a REST API or a messaging API. All right. Thank you.